Welcome back, I'm Alex. We're in the shop today with something a little different. This very nice looking 4th gen Toyota Tacoma, but not just any Tacoma. This is the off-road ready Trail Hunter edition, and I may have been a little bit critical of this truck previously.
This is huge. It's a mid-sized truck. That breakover angle's gotta be trash. What the hell is this thing doing up here? Why would I want a hybrid engine in that? I don't get it.
So maybe, just maybe, my mind could be swayed with the mini series we are about to embark on with this truck. Today, however, we are going to be focusing on the 2.4 liter Iforce Max inline 4 turbocharged hybrid engine in this truck. We're going to take a deep dive into the mechanical workings of this engine, talk about some specs, power figures, towing figures, as well as some things that I quite like about the design of this engine. Next week, we'll be talking about some things that I may not like about the design of this engine, some questions or maybe concerns I have if I was to buy this engine, and I'll link that video down below in the comments when it drops so you guys can get the full picture in my humble opinion, for whatever that's worth. Then we will be doing a full in-depth review on this Trail Hunter off-road package, talking about all the off-road equipment that is offered in this Tacoma, as well as taking it out in the real world and actually seeing how this off-road truck performs.
Yeah, we're pretty hung up.
The last bit of housekeeping before we get going here, I desperately wanted to tow with this Iforce Max engine as well as put on my fuel economy loop, but I am not going to do that with this truck because I just don't think it's fair. We got bigger tires, we got a freaking snorkel on the thing, we got a roof rack, it's wider. So I am going to wait until I can get my hands on a normal 4th gen Tacoma, or until Toyota supplies me with one. That way it's a fair shake.
So this is the 4th gen Tacoma, and well, these dropped in 2024, and I think the styling is pretty good. I actually quite like it. We have the Trail Hunter with us today. Some people may not like how much this thing stands out with its gold rims, its lift. We got the roof rack up there as well as the snorkel, which actually sounds really good.
Isn't that insane? From factory, it sounds like that.
The biggest thing for me that stands out about these newer Tacomas is just like how big they are and almost encroaching on a full-size truck. I mean, this thing actually weighs just over 5,400 pounds, which is quite a lot for a mid-sized truck. Now, what we're really focused on today is what's underneath this hood.
Well, gone are the days of the simpler, naturally aspirated V6 engines in these Tacoma trucks. Toyota has opted to go for a smaller 4-cylinder turbocharged with a hybrid option engine platform, seemingly throwing everything at this engine except the kitchen sink. And well, there are a couple different configurations to this engine platform. The first configuration, and the engine specifically in this truck, has a hybrid motor stuffed between the transmission and the back of the engine. Toyota calls it the Iforce Max, and it puts down a segment leading 326 horsepower, 465 pound-feet of torque, of which 100% is available at only 1,700 RPM. So on paper, it looks pretty freaking awesome. Now, we may talk a little bit about that later on if we have time. The non-hybrid engines come with 3 different power outputs. First is the base model, which comes with 228 horsepower, 243 pound-feet of torque. Secondly is the manual transmission option, which comes with 270 horsepower, 310 pound-feet of torque. Thirdly is what Toyota calls the core engine, and that's what most people will most likely end up with in their Tacomas. And that comes with 278 horsepower, 317 pound-feet of torque. Behind this 2.4 liter, we have either an 8-speed automatic ACE transmission, or like I mentioned, a 6-speed manual, which you do not see in 2025. That could be a very fun truck. In terms of gearing, the standard gearing and what gearing this truck has is 358s, but if you get the 6-speed manual transmission, you have a very aggressive gear set. 430s come with this truck, which is interesting. As for towing, more interesting stuff. With the non-hybrid core engine, the max tow rating on these trucks is 6,500 pounds. However, with the more powerful hybrid motor hooked up to this 2.4 liter engine, the tow rating actually falls. It's only 6,000 pounds of max tow rating, which is far below both Ford and GM's max tow rating on their mid-sized trucks. Let me know why you guys think that might be. Fuel economy, we have the best in the segment, 24 miles per gallon combined city and highway. So not only do you get the most powerful engine, you also get the most fuel efficient truck along with it. Pretty impressive. So this is a 2.4 liter inline four, also known as the T24A. You can tell that this is the hybrid version because of these very bright orange power cables. One thing I first noticed when I'm looking at this, it looks like this angle is slightly tilted to the left here. We got our turbocharger right down there. And this is a dual overhead cam setup with 4 valves per cylinder. We have a forged crankshaft, forged connecting rods, as well as an open deck aluminum block. This engine block has 2 sections to it. And instead of this engine using a normal main bearing or individual main bearings to hold up or bolt up the crankshaft, it uses a solid cast piece of aluminum to hold the crankshaft up. So not only do we have a fully forged crankshaft, forged connecting rods, we have a solid single piece of cast aluminum bolting up the crankshaft. That's going to give this engine exceptional bottom end strength. And it's the first time I've sort of seen an engine design like this, and I really like what Toyota is doing here. Rounding out the rotating assembly on this engine, we have T-shaped cast aluminum pistons. The T-shaped design allows Toyota to use less material in the pistons, but still maintaining that strength and durability that you would need and want in a forced induction engine like this engine. But as we'll talk about later in the video, this 2.4 liter engine has a massive stroke, meaning that the rotating assembly is going to have a lot of mass going up and down with that large stroke. So if we can shave off any weight to that piston, it's going to make a big difference. Underneath those pistons, we have oil jets or oil sprayers, which we are seeing more and more common on forced induction engines because they create a lot of heat, and having oil squirted on the underside of that piston is going to help cool the piston, help cool the cylinder walls, help cool the combustion chamber, which is going to help reduce emissions. And apparently, from what I've heard, that is one of the biggest reasons why Toyota went with this engine or designed this engine, was to lower emissions. So we're going to see emission reduction in this engine as a reoccurring theme. Like I just mentioned, this engine has a very large stroke, and in fact the bore to stroke ratio on this engine is very deep, making this engine a very deep under square engine, which I quite like in a pickup truck. In fact, out of 19 modern pickup truck engines, this is one of the deepest under square engines. Only the 6.7 Cummins, as well as the 3.4 liter Iforce in the Tundras, is more under square than this engine. And we talked about this at length, but with an under square engine with a large stroke, it gives a very good torque advantage, especially down low in the RPM range, which is exactly what you want in a pickup truck. Another advantage of having a heavy under square engine is an increased thermal efficiency, essentially meaning that this engine translates the energy in its fuel into mechanical energy at a more efficient rate. This is actually the most thermal efficient engine in the segment, and that's going to lead to better fuel economy, but again, more importantly to Toyota, with this engine, reduced emissions. With this beast having such a large stroke, being such a heavy under square engine in an inline four configuration, means we're going to have some balancing problems. And so Toyota has put in a balancing shaft, which is run directly off the crankshaft via polymer gears, which is interesting. Both Ford and GM in the segment use steel gears to run their balancing shafts. However, using polymer gears is lighter, and it should add to better noise reduction as well as vibration reduction. So there is definitely an upside, and keeping this engine lighter reduces fuel economy as well as emissions. The last major design element of this engine's rotating assembly is that the crankshaft is offset by 10 millimeters, I believe to the driver's side, essentially meaning that the center line of the cylinders and the center line of the crankshaft are off by 10 millimeters. This does a number of good things. First of all, it allows the connecting rod to be closer to 90 degrees at peak cylinder pressure. So a lot more of that force is going to be directly driven down onto the crankshaft, and it allows this engine to produce a lot more torque. And as we've seen, this engine does produce a ton of torque very down low in the RPM range. Secondly, is that the internal friction of this engine is going to be reduced. Why? Because our connecting rod, like I mentioned, is at closer to 90 degrees. So when we are at peak cylinder pressure, a lot of that pressure is directly going downwards and not going against the thrust side of the piston against the cylinder wall. So it reduces the friction of the piston and the cylinder wall, meaning that we have a more fuel efficient engine, and critically, we are going to have less emissions produced. In terms of oil, this engine is going to be running 0W20 weight oil, which does seem pretty standard for most modern lighter duty pickup trucks these days. We do actually have a dipstick. Don't tell Stellantis that, they don't like those. We do have a variable displacement oil pump, which is going to be pumping oil through the engine. Like it sounds, variable displacement. The ECU is going to be able to tell this pump how much oil is going to be pumped through the engine depending on RPM load. So when you're at idle, we don't need to pump as much oil, volume, or pressure into the engine. That is going to save fuel economy as well as reduce emissions. Moving up to the top of our engine, we have a dual overhead cam setup, as I mentioned, 4 valves per cylinder with the exhaust valves filled with sodium for heat control. We also have a 2-piece aluminum head, which is interesting. One thing that I do like about this engine is we have a single timing chain, keeps things pretty simple. This engine does come with variable valve timing. You can see on our exhaust camshaft as well as our intake camshaft. We have some actuators there. These are actually hydraulic actuators. I would have expected electric, but we'll go with it. Essentially cam phasers, same thing there on the EcoBoost engines, although these are probably engineered a little bit better. No offense, Ford. Essentially what this does is it can shift the timing of the camshaft. So when we want to gain more power or have higher RPM performance, we can retard the engine timing. Or if we want to increase low-end torque, potentially limit emissions, we can actually advance the timing on both the intake and the exhaust side, and we can do so. Lots of technology in this engine. Next is the fueling system, which is right on top of this engine. You can't really miss it. Toyota uses both direct injection as well as port injection, which I really like. And they've been using this style of fueling, dual injection fueling, for a number of years. In fact, the predecessor to this engine, the 3.5 liter V6, also had dual injection. Toyota calls this system the D4ST, and well, we'll get your peepers in here and show you what I'm talking about. So I wasn't lying. Right on the top of the engine, we have our high pressure fuel rail, and our injectors go directly down into the cylinders. Now this system, the high pressure side anyways, is running north of 4,000 PSI, not quite up to diesel specs, up to 30,000 PSI on some of the new modern diesel engines, but high enough that we definitely need a high pressure fuel pump, which is sitting right here. We have high pressure steel fuel lines and obviously our high pressure steel fuel rail that goes to each injector. So it's not the most simple fueling system, but I think Toyota does a very good job with this. One thing from the Car Care Nut YouTube channel, he mentioned, and this gentleman seems to know Toyota engines better than anyone else I've heard on the internet, so check him out. I'll put his channel down below in the description. But he mentioned when Toyota moved this high pressure fuel rail and the injectors at the top of the engine, if you need to remove this valve cover, you have to remove basically this whole fueling system, which could be quite the pain. You got to pull the injectors out apparently, and pulling high pressure fuel injectors out can be a little bit of a nightmare at times. It could make future maintenance on this engine a little bit of a doozy. Running dual injection fuel systems like this engine does, I think, is the best way to go. It's the best of both worlds, and I've said that before. You get the advantages of direct injection, which is better throttle response, better fuel economy, lowered emissions, as well as some better power. Yet you don't have the carboning up of the intake and the intake valve because we have port injection alongside direct injection. Now you might be saying, well, Alex, direct injection does create more particulate matter, and that is correct. But Toyota, when this engine is not under heavy loads, running at lighter loads, actually utilizes port injection more heavily, and that does reduce particulate matter. So again, it's sort of like having the best of both worlds. You do get a little bit of added complexity, but I think the results are arguably worth it. Next is the turbo on this engine, and there's a couple unique things that Toyota did specifically for this Tacoma, but we have a dual scroll turbo, essentially meaning that the turbo inlet is cut into two different chambers, and cylinder 1 and 4 go into one chamber, cylinder 2 and 3 go into the other chamber. This helps to reduce pumping loss. Basically, the exhaust pulses aren't fighting each other. They have a clear inlet right into the turbo, and it helps to increase low-end torque, helps to reduce turbo lag, a number of benefits. It's the same style of turbo that GM uses on their 2.7 liter Turbo Max. The turbo on this engine is both water and oil cooled. It sits just down in there. We also have a vacuum exhaust wastegate actuator, which is very old school, dare I say, but it's not the only old school thing that is very specific to this Tacoma. On other applications of this engine, we use a water to air intercooler, which is more efficient, but on this Tacoma, we use an air to air intercooler. You can see there's our charged air outlet, comes in, and that is our charged air going into our intake. So we use an air to air intercooler, not as efficient, but it is so simple, and I really, really like it. It just makes for a very, very simple solution. In terms of our vacuum wastegate actuator, if you know Toyotas or you know the Tundras, the 2022 3.4 liter Iforce engines, they had some issues with their electronic wastegate actuators. In this engine, we have gone back in time with a vacuum actuated wastegate actuator, and it's just simple, it works. It's not gonna be as lightning fast as an electric one, but I think what Toyota is counting on is this hybrid electric motor to pick up the slack of any turbo lag if it comes along, having a slower vacuum actuated wastegate actuator. The benefit though, which I think is very important to note, is that it's just gonna be more reliable in my opinion. It's a mechanical actuator, and if it does fail, it should be a rather cheap and easy repair, unlike those 3.4 liter Iforce engines in the Tundras. Another thing that's very unique to this engine, specifically in the Tacoma, is that our turbo does not have a separate cooling system. This engine in this truck only has one cooling system, whereas when this engine is in other platforms like Lexus SUVs or the Toyota Highlander, there is two separate cooling systems. The turbo, as well as the water to air intercooler, has its own cooling system, its own radiator, its own electric coolant pump. So once again, Toyota has just gone back to simplicity with this engine in this truck, and I really, really like that. What is not so simple on the cooling side of things with this engine is that Toyota ditched the standard thermostat, going for a coolant control valve, and there's a number of benefits that come with this. First of all, the ECU can control when and where to flow coolant to different parts of the engine, meaning that the engine, first of all, is going to heat up much quicker. Also, it's going to stay at a much better optimal temperature range when at different operating temperatures, different loads. This is going to reduce the wear of the engine because it's at a better temperature, especially at startup, because the most wear an engine receives is during startup because it's not at operating temperature. So the quicker you can get an engine up to operating temperature, you're going to receive less wear, it's going to be more fuel efficient, and critically, you guessed it, where you're going to lower emissions. So that's the benefit of having a coolant control valve. The downside is it adds a lot of complexity, and this is going to be a plastic coolant control valve. And looking at other engines that have implemented coolant control valves, like the 3 liter Duramax, they're having a lot of issues with that. There are other engines or modern engines that have used plastic coolant control valves that have had some issues. So we'll keep an eye on that. So as you saw, this little engine is packed with technology. And before this video runs on too long, I'll give you 5 things that I really like about this engine. First, as you guys probably guessed, I love the fact that it is a heavily undersquared engine, as well as the crankshaft being slightly off-centered. I think it just makes for incredible ability to make torque, and that's exactly what you want out of a pickup truck engine, so I really, really like that. Secondly is the bottom end strength that this engine is going to have. fully forged crankshaft, fully forged connecting rods, as well as the two-piece block, or the base plate, as I'm gonna call it, that locks in that crankshaft instead of using individual main caps. Look out, this thing is going to have incredible bottom end strength. Thirdly, I like that this engine comes with both direct and port injection. As I've mentioned, sort of the best of both worlds. Both Ford and GM's four-cylinder engines in this segment do not come with dual injection. They are only direct injection, which, as we've mentioned, does lead to a number of consequences, which this engine is just not going to see. Another thing I like about this engine, dare I say, if you need to work on the turbo, replace leaking fittings on the turbo, it is up front here. It's right here. Yes, it's not the most accessible turbo in the world, but it's also not buried under the cab like the EcoBoost engines are. It's not buried in between the banks. It's pretty accessible, and realistically, if you are planning on keeping this engine for a long time, odds are you're probably going to need to access that turbo at some point to do some repairs or maintenance. So I like that Toyota made it accessible, and it can be removed without removing the engine, without removing the cab. I like that. Another little thing that I like about this engine is that we have a belt-driven water pump. It's simple, probably cheap to repair or replace, and it's accessible. It's right up front here. And there's a number of simple things like that on this engine. We talked about the mechanical wastegate actuator on the turbo instead of using an electric one. So yes, there is a ton of technology in this engine, but Toyota also did some sneaky little old school things like a belt-driven water pump. I like to see it.
Something I forgot to mention, which I do like about this truck, first, we do have an oil cooler, something not every light-duty truck engine has. We also have a metal oil pan. It's a two-piece oil pan. We have aluminum as well as a steel bottom. Unlike other engines in the segment that use plastic oil pans that have had major leaking problems, so I like to see that as well.
So I think there are a number of really good things about this 2.4 liter Iforce turbocharged engine in these newer 4th gen Tacoma trucks. In general, I think the benefits of this engine over its predecessor are you're making way more power. It's in a smaller, more compacted package, as well as being lighter, more fuel efficient, especially with that hybrid motor, as well as reducing emissions, which I think was most critical for Toyota when building this engine. Is it going to be more reliable than its predecessor engines? Only time will tell. You guys can let me know what you think. Are you excited about this engine, or are you going to be steering clear of this thing because you're a little bit allergic to the old turbocharged engines? Let me know what you think. As I always say, I like hearing from real world truck owners. If you guys did like the video, don't forget to leave that thumbs up. And if you like cool stuff like this, do not forget to subscribe. We'd love to have you on board. Next week, we're getting off the Rainbow Express. We're going to be diving into what I don't like about this engine, and you guys don't want to miss it. Anyways, enough of me. We'll see you on the next frickin' video.